I'm very, very excited about this next panel and the group of amazing speakers that were able to join Republica for this session. I'm really excited to have them all, but I'm just going to introduce the topic and the moderator, and I don't think we could have had a more qualified, more exciting person to host this panel as Andrew Lamb. For the next hour, we're going to be discussing how to build prosthetics using maker technologies such as 3D printing, and how to build such products for people who are both world-class leading athletes, champions, such as Denise Schindler here with us, but also the survivors of conflict, people who live under very difficult and unprivileged situations. And here to host the session, as I said, is Andrew Lamb. Very, very happy to have him at this Republica. Andrew does many amazing things, and I'm just going to share a couple of those with you. He's one of the core members of Field Ready, which is an organization that uses disruptive technologies to innovate supply chains for disaster relief. He's part of the Global Humanitarian Aid Initiative in Geneva that combines different groups, NGOs, companies to promote innovation in digital fabrication. He's an advisor at the World Bank on open data. He's working on a number of new, really exciting initiatives, such as Makepedia and MakerNet, trying to unite makers around the world to give them a voice and lobby and encourage them to really engage more in collaborative production. Andrew's thankfully also going to be here with us for the rest of the day, so in case you want to approach him after the panel, we're going to have a workshop later on this topic, where I think all four of the speakers on the panel now are going to be at the Makerspace, so I hope you enjoy this session and the workshop that we've got coming up just a bit after this. And Andrew, over to you.
Thank you for your incredibly generous introduction, which, as a British person, I find very embarrassing. It's an incredible thing to have these three people on stage. There's been an awful lot of talk about 3D printing and prosthetics around the world. And I think the three people that you're going to be hearing from today are genuinely some of the leading figures in this, this rather fraught and fast-moving area. 3D printing has been around for a long time, and it's been used for all sorts of great reasons and all sorts of, well, mediocre reasons as well. But the stories you're going to be hearing today are essentially about becoming one of the world champions in sport, I would say, in general. But actually also about human survival and how 3D printing and for prostheses can really help with that. So let me introduce the panel first, and we're going to hear a little bit about the stories and what they want to say. We're going to have a discussion on some of the common areas to try and tease out where the common areas are at these very different approaches to 3D printing and prostheses. And then we're going to open up for a discussion. So, if we can start with Sama. Sama is the founder of VecBox and is a new media artist and an entrepreneur from Palestine. And he's been involved in the make space, the innovation space in Ramallah. And he's got a really interesting project underway at the moment around making prostheses. Then we're going to hear from, we're going to be hearing later from Asem, who's part of the Refugee Openware initiative, and specifically part of their work to respond to the Syrian crisis, the conflict in Syria, and doing some really interesting work there for people who are coming across the border from Syria into Turkey, and people who are refugees from the crisis, and helping them with 3D printed prostheses. And then Denise is a gold medalist world champion of track cycling, and an Olympic athlete who it was a silver medal in London 2012, and if I got this right, it's a gold medal in Rio 2016, hopefully. And it's amazing that in the preparations that we've had for this panel, the three people that we have here have got very different stories, but very, very common passions for the possibilities around 3D printing prostheses and making the prosthetics. Can we start actually with Denise and tell us your story first, please? Thank
you. Yeah, hello. I'm very excited to be here and share my story with you. For the beginning, I would like to introduce myself. I'm Denise Schindler. I'm a paracyclist, and as Andrew told, I've been track world champion. I'm current 4th-time vice world champion, silver medalist in London. We will see what comes out in Rio. So what is special with me and why I'm talking about prostheses? I had an accident when I was 2 years old. I hit the train and I won, but I lost my leg. So since then I have to use a prosthesis to walk through life. And as I'm a girl, I'm not having only one prosthesis. I'm having different kind and variety of prostheses for my special kind of needs I have. But I'm not able to buy my prosthesis, I would call them shoes, at Zalando. I'm gonna have them 100% handmade with a lot of love because they are very individual. And the guy who's doing this, you can see him in the picture, is my prosthesis expert who is doing this since 25 years for me. And he helps me a lot on this way. But the way prostheses are made now is a very, very traditional way. It's a handcrafted way, which takes a lot of time, a lot of fitting, a lot of personal time on the expert, which when he's producing it, when he's adjusting it. So you can see here, everything is based on a blaster cast. So that's how it starts, and then it gets a lot of adjustments. So it is a very traditional, old-fashioned way how my prostheses are made right now. So 1.5 years ago, I started to work with Autodesk, and we had the idea of making prostheses in a different way, in a new way. And it all started very funny, with Mickey scanning my limb with a handheld scanner, and just to have my limb in a 3D model, so that I'm now a 3D patient, which everybody can work on. We loaded this file up, the scan up, into Fusion and started to work with. And Fusion allows us to, on the one hand, have organic forms, and on the other hand, fit it to the needs of mechanical engineering. So in the software, the experts are able to do adjustments on the scan, which has to be done to make the socket fitting, and they can do a lot of modulation on that. So, which is a big, big thing in the software that we can do. You see the crazy guys on the left and the right. That's Paul. He's from London. He's the Fusion expert. Then we have the Musketeers in the middle, which is Mickey from Munich, my prosthesis expert, who is somewhere on the countryside. You don't know the town, believe me. It's somewhere in Bavaria. And that's me on the right side. I'm an athlete. I'm not at home, not at any time. I'm always worldwide around. I'm on training camp. I'm competing everywhere. So basically, I'm just available per mail, per phone, or per cloud. So that was one of the main benefits we had in loading it up online, working in Fusion, which is cloud-based, that everybody could give their ideas and share it and work on it in the cloud. And yeah, we had now a data which was available. So we had, like, when Paul had the first draft of the leg and he thought he's done, then I gave him a call that something is not working and I need it different. And when he did that changes, my prosthesis expert came and said, no, that's not working too, because Denise had a great idea, but in practical, that's not working. So he could do like a lot of changes, and I think till the first draft was printed, we had like 60 different kind of prosthesis drafts, so it's a lot of changes that we have there. And which is great in the cloud, that we have a lot of transfer know-how, so everybody can give his ideas into that. And yeah, in the end, when it's done, after 60 drafts of prosthesis, we've been able to do a first 3D printing and send the file to the 3D printer, which was pretty much exciting, and which happened in San Francisco at Pier 9. And yeah, we've been able to print it. And I give you a short video on that. Pretty easy, huh? So why taking 1.5 years? Well, what came out looks like this. Well, it's laying in the bag. I will show you. This is the second version of my leg. And I think the microphone, is it working or not? No? I can scream if you want. Better? Yeah. So this is the second version of my cycling leg. It has special adaptation. It is aerodynamic. It's tried to have the best power output. But as you see, most of the people who see a prosthesis think, where is the foot? I don't need one, I'm cycling, so I just click right into the pedal. So that kind of special adjustments, which are very specific needs in cycling, can be done very easily on a software like Fusion. So my microphone is running away from me. So the hair is not fine anymore. So no photographs anymore. Is it okay? Good. Okay, good. So, yes, so that's the second version. It's running again, but it doesn't matter. We do that. So it's made, printed with polycarbonate, and maybe you just give me that one. Is that working? Yeah? Okay, good. So that's the second version we got. I just got it a week ago. The first version I got, I tested it in endurance rides and sprints on the track, and I got a lot of feedback to Autodesk and had a lot of expectations, like saying, okay, this has to be more stiff, it has to be a better power output, it has to be more aerodynamic. We've tested it on the track, and the first version was not very aerodynamic, so we changed the shapes. And that's very interesting because with the new kind of printing, we've been able to get new shapes for the prosthesis, which is not possible in a normal handcrafted way. And last week, there have been 2 guys who've been pretty interested on my prosthesis. Well, we've been able to show up last week at the Hannover Messe, Angela Merkel and Barack Obama, obviously, my prosthesis, and we've been able to share our vision of how prostheses are made in future. And I was really impressed from Obama, who really recognized the benefits on the new way of making prostheses right away. And we talked about how in future this will minimize the production time in general, how the costs will tremendously go down for prostheses through this way of production, and how we as well can use new kind of materials, use soft and hard materials through printing to reduce pressure marks. So it was a very nice exchange with both of them on that topic, and yeah. In the end, it's all about a perfect fitting prosthesis. And what I would like to open up in your mind is like, for us, a prosthesis is like a shoe. If we have a sport shoe, we can run. If you have a cycling shoe, cycling prosthesis, we can go cycling. If you have a fancy leg, then we can go out and dance. That's basically, it gives us the freedom to choose what we want to do and to give us back the life that we had before. So I think absolutely that 3D printing is a chance for everyone, especially for the average amputee, to afford prostheses with special needs and to open up the world that he had before. And yeah, that's my vision, to open up this world to the average amputee and especially to kids, because I experienced a life or a childhood which I was not very into sport. I had no special legs for doing sports, and I would be very happy if this would change in future. Thank you.
Thank you very much. To create a better world, amazing way to finish. I think an incredible story you've set out there. Should we move up a bit now that we can, if we just move around quickly. Yeah? Okay. And now, maybe we've heard from a world champion. Asem, maybe you could tell us your story of working with survivors.
So I am Asem Hasna. I am from Syria. 3 years ago, I was studying mathematics in University of Damascus, but I had to drop out to work as a paramedic when the war started to help saving lives. In 2013, I was injured and I lost my leg while I was doing my job. So I had to go to Jordan to get some special medical care. And there, after 1 year of rehabilitation and surgeries, I met Refugee Openwear through Killing Kleinschmidt. So I met them and they were working on the 3D printed prosthetic project for Syrian refugees.
And one of the things that I've understood that you're doing is you're working very closely with, essentially as a maker, working with the users, the people who've been affected, and you're not seeing it as trying to create one product to fit everyone. You're trying to cater to every individual person. Could you say a little bit about how you engage with the people who you work with?
Yeah, actually, before I become a maker, I am an amputee. So when I try to design something or to make something for the patients, I'm making a need for them, not a product. And we are trying to fit every individual patient separately. So when we were in Jordan, we would love to include the patient in the design process, in the printing process maybe, and in the fitting process. So the patient will design his own prosthetic. He won't be a patient, only a patient. He will help with the process of making his own prosthetic.
Fantastic. And can you tell us a little bit about this video you want to show?
Yeah, so the video we will show is a video for a Yemeni boy who was injured because of the Yemen war. When we asked him about his hero, he said he loves Ben 10. So he wanted a Ben 10 hand. So we worked with our designers to make the hand and also.
Should we play it?
Yeah.
Yeah, thank you.
Oh, can you? The sound. Yeah, the sound. Yeah, so he asked us to make a Ben 10 hand, so we made this hand with a small watch to make the creatures for him.
Thank you very much. Thank you for sharing that. How old did you say the boy was? How old did you say the boy was?
He is 6 years old.
Okay.
Yeah.
Can you give a sense of what else is going on? Is what you're doing an unusual thing? What else is Refugee Openware doing? What else is going on to support, at least in the networks that you know of, to support Syrian refugees who've lost limbs with these sort of prosthetics?
Yeah, so Refugee Openware basically is trying to use the technology, to employ the technology to help people who have lost everything, like in the crisis-affected areas like Jordan, Lebanon, and Turkey. The other thing is to help to develop this 3D printed prosthetics. So we can make them maybe locally inside Syria, or we can make them outside by using the 3D scanners to scan the patients and send the data, make the prostheses and send them back. And also, I told you to include the patients in the process of making the prosthetics. And also there is another things that RO is doing, not only for prostheses, but to use the technology in general to help refugees.
Absolutely. And we've heard on the stage today, early this morning, from a number of different initiatives, from the perspectives of refugees and organizations trying to help refugees, from the support that the German government is giving on this stuff. And I think we've been learning a lot about these different perspectives, but it's great to hear of a particular piece of technology and to see these individual people that you're helping. Sama, can we hear a little bit about what you've been working on, the prosthetics that you've been working on? And as I understand it, it's almost like it's somewhere in between, the Olympic standard, the sort of what might be described as the high-tech side of 3D printing, and the more sort of grassroots 3D printing of what's possible to be made in a conflict situation or for people affected by conflict. Where are you in this sort of spectrum?
Well, we started actually after watching a lot of wars in the Middle East, from Syria to Gaza to many different people, and facing a lot of people that they lose their limbs from civilians. So we had to think about idea to make it easier for people to get their prosthetics back. And it's 3D printed, also low cost, but at the same time, it could be as close as a human hand that can be react or act. So the thing is that what we are building now, that we're creating a prosthetic limb, a smart one, that it's just as simple as plug and play. So the patient, he will take it, just wear it, and it will automatically understand what kind of movements that he wants to do. So it will open, it will close. Now we are making like 12 different movements in one arm. Basically, it works on gathering data from different kind of patients that they have different kind of cuts in their arm. So we're gathering the data of the EMG, the muscle. We put muscle sensors on them, and we grab all the data, and we actually cluster all this data for the different 12 movements of the hand, and we do some machine learning on the arm itself, so it will automatically be smart and understand many different aspects that they can go to it.
Amazing. So the customized design, the individual care again, but then actually taking it to the idea of a smart prosthetic and using the machine learning aspect.
Exactly. So that's one of the goals, that to make it low cost and easy, and also as close as a human movement.
Incredible. How are you able to do this in Palestine?
Well,
I mean, you face all sorts of restrictions in the context that you're working in.
Yeah, of course, but when you have a passion for something that you want to do it, you just go and do it. You'll find your way. It doesn't matter where you are. It doesn't matter what you do, just do it.
Amazing. And so but it takes a lot of work, eh? It
is hard work. Yeah, I had to make some good researches between different technologies. First of all, I found that a lot of people are focusing on EEG technology.
Okay.
But
Can you say what EEG?
Yeah, it's a sensor that you read the brain waves that you can control robotics with it, maybe. But I thought it's a bit complicated, and it's not relevant that someone that he lost his arm and you put something on his head. That doesn't look cool. So yeah.
We struggle with microphones on our heads, so you know it's.
You look cool.
I have less hair to deal with. So could you say a little bit more about the data you're gathering? So you're a maker, and the way that you engage with users. A similar question to what I asked Asem.
Well, we engage with users. Actually, now we are on an early stage that we got the algorithm works on one of the open source 3D printed models. After that, we will start creating the real model that it will fit, because first we will create the arm only. Yep. And after that, we will create the extensions that they can add it to the arm, and depending on what is his need. Okay. So inside this extension, there is the EMG sensors.
So you're developing a prototype which will allow that to be adapted over time.
Exactly.
Thank you.
But engaging with the user, actually, we just go to some institutes that they take care and give just basic prosthetics to victims. Okay. And we went there and we gathered data from these people. We have data from 4 different people that they lost their arms. And we have data from 25 people that they have their arms. Yeah. But the surprising thing that we found, the signal is more powerful. It gives us more powerful signal from the people that lost their arms than the people that have their arms. So that's made it even easier for us to differentiate between signals. And
can you just so we have an understanding of the context? I think many of us can imagine how. We've heard how you lost your leg. We've heard a little bit about, we can imagine how people might lose their limbs in Syria. What kind of, how are people affected in Palestine? What are the main causes for people to need prosthetics?
Well, there's a lot of them lost it in war. Okay. Sometimes also in an uprising, because actually, in the uprising, the Israeli army, they used illegal weapons. So it was like the exploded bullets. So some people, they got the bullet and exploded, so they had to lose their arms or legs.
So it's still very much a conflict situation, okay.
Regardless to the normal accidents that happens. So, yeah.
Well, it strikes me in that case that the thing that you have in common is that you're in many ways all survivors and you're all champions. But the difference between you, I guess in some ways, is that you're a user and you guys are makers. So how do you find, Denise, how do you find engaging with the makers, with this amazing team that you have supporting you? What does it feel like to be involved and working with them in creating these technologies?
Well, it's like creating a new way how in the future things will happen, and for me, it's I'm very happy to give something back, because I've been very lucky in my life, and as a world-class athlete, I have a lot of support and sponsorships to get my special legs. But it's great to give something back of know-how to establish that new way of producing, and to maybe open up kids a new way of life and future, and to be able to participate in sports classes, because it's not normal that they can, like, if they are in a soccer game and you are amputated, you're the last on on the ball to kick it. So until you're there, the rest is gone. So it's nice if we can, or if I have the chance to change the world a bit on that, and that's the best thing for me to improve.
To share the love a little bit.
Yeah, absolutely.
So, in practical terms, one of the things you were talking about there is that you were sharing some of the data and some of the, you're looking to share some of the lessons that you're learning, or even the expertise around what you're doing. Could you say a little bit more about what you're interested in there?
Yes, well, it took us a long time until we had really found out what kind of, how the prosthesis has to be that it works for cycling. So it was a lot of try and error, and then in the beginning, nobody sees like you see Hollywood, she's on the podium, she's won the race, and it's fine, but in the background, it's been a long way and a very struggling and challenging path to get there. I had a lot of inflammations, I had a lot of surgeries, I had big problems with my prosthesis. It didn't work how I wanted to have them. I haven't been able to train so many hours, then I had to pause again and had again another surgery. So it was really a hard way to get there, and
sounds painful.
Absolutely painful, yeah. If you have inflammations and you have to walk on it, it's not fun. So but with all that experience we have, my prosthesis expert, he's over 60 years old, so he's got 40 years of experience in that field. And with my experience I have on a very, very high level, and this has really to fit. We are able to give the experts from Autodesk a lot of feedback and a lot of detailed information. And we're really challenging them. I think a lot of times they just thought, oh my gosh, what do they want from us?
Okay.
But, well, this makes it better in future. And I think such a program has the chance to have available data, which means that in future we can establish a higher, I would say, yeah, kind of better fitting. Yeah. So if you have a scan and then we have a programmatic filter that runs through and says, okay, this is happening, this is on a scan, this is bony, this is something like that, then the program can lift up the level a bit higher.
Raise the average.
Yeah, and orthopedic technicians, which are very, very good, are very, very rare. So really good experts are not very often, even not in Germany, and especially in countries where a crisis, where war is happening, you don't have no technical experts in front who can help. So this will help a lot.
Absolutely. Can I ask then, Asem, on that question, what kind of technical expertise is available to you and your colleagues, and maybe the same to you, Sama? And what kind of know-how or what kind of data would be useful?
Yeah, actually, the experience in prostheses in the Middle East in general is really poor. And because of the conflicts, there is a big need for this. So when I was in Jordan, I went through almost 1 year of suffering until I get my first leg and I could walk. And I still suffering until now, because I was in Jordan. I'm only here for like 6 months.
In Berlin?
In Berlin, yeah. So I hope that in future, the people will have access to this advanced prosthesis, not only to be able to walk, to be able to run, buy your running shoe or your cycling shoe, so you will be able to do whatever you want to do. So what we need is to build the infrastructure for this experience, to train technicians, to train people, to get the feedback from the patients themselves and to involve them in the process of making. So we will get a lot of valuable information from the patients themselves.
And hopefully to be able to kind of build that area, as an area of expertise within the Middle East.
Yeah.
And do you agree with that, do you think? Is that what's needed?
Well, yes, but for the model that I'm building, also we need something about the hardware design. It's really highly needed. Also in machine learning now we are dealing with just some kind of data, or if we need to gather just a massive of data, of course we will need something else much better. Okay. So yes, we need some nice, good expertise people about hardware design, because now we are using an open hardware controllers, just like a Raspberry Pi, Arduino, and these stuff, and with that, after to take it to the next level, of course, we need serious hardware design.
Yeah, I mean, I'm aware that Palestinians have a very strong tradition of technology and engineering. Some of the best engineers I've ever met have been Palestinian, so there's, I think that your work would obviously make a lot of sense in the culture that you're from. How do people react to you doing this kind of work, or how do they see prosthetics? I mean, is it seen as a charity thing? Is it seen as a rights thing? Is it seen as a hobby?
A hobby? I don't think it's a hobby, but
okay.
Well, it's more like building a prosthetic like this. It's like solving a serious problem with people that really need it. Maybe they look at it from a charity side. So okay. Yeah. So you can actually give it, and I thought about it the first time. It's a charity side, yeah. So yes, we have a lot of victims that lost a lot of arms because of nothing. So yeah.
And how have people reacted to your work, Asem? What have the attitudes that you encounter when you work with people?
Yeah. So let's take Zain as an example. This kid.
Okay.
His name is Zain. So when we met him the first time, he was really scared, because all of his body was burned and he lost his hand. But when he started to see something, started to see this bent-in hand, he started to be more relaxed. The first day he didn't take off the hand. After, when he slept, his father took the hand off. And when it was, we had to do some maintenance for it, so we spent like 1 hour to take the hand from him. So we got a very good feedback, and because all the patients in the Middle East, the Syrian or Iraqi or Yemeni or whoever, they really want to get something. They really want to have the access to this, to have the. So we have to have this open source kind of prosthesis.
Yeah. And then the attitudes to the way people see sort of Olympic athletes using high technology. What kind of attitudes have you encountered?
Well, I think often at times they get inspired to don't see barriers anymore. Yeah. It's like they see what I can do, how I live my life, how I choose my path, and I walk my path, and I cycle my path. And I think for them it's the inspiration not to stop and just to see the things they can do, and just start doing the things they can do, and as well they start to ask for things and not to stop. And like asking for things they want to have to do the things again they did before, and I think that's one of the biggest things I can do.
But do you ever get people saying to you, like, you hear a lot about cyclists saying it's the technology which is really, or it's certainly true with Formula One racing cars, it's the technology that is helping people to win. Now, I know you do a huge amount of training all the time, and how do you feel about that, the relationship between the idea that you're the athlete and the technology is an enabler, but people might see the technology as being part of your success?
Well, it's a yin-yang. It's always both. If I'm not in the shape and I'm not fit enough to power it out and have all the muscles in my legs, every aerodynamic bike will not work. So I have to move it and bring it to a certain kind of speed until aerodynamic works. So it's always both sides, and also with prostheses and the gear, the equipment, everything has to be 100%. So it's both. It's the play between being the best athlete that you can be on the 100% and having the best gear that you can have. So I think that's very interesting in cycling.
And how are you feeling as you run up to the Olympics this summer? Are you feeling like the technology is as good as you need it to be? Do you feel like, and I'm going to ask you similar questions, what do you think the future of this in the short term, of course, for you, but in the longer term, what do you think the future looks like for these kind of technologies?
Well, for me, I feel well equipped. In my mind, I'm already at the starting line in the Copacabana from my time trial. So I'm fine. I really am very confident on my prostheses and how things develop. But in the long term, I see a lot of other people starting doing marathons, starting doing normal cycling events in their hometown. So that's what I see in the future, that they are able to buy their running shoe, running leg, cycling shoe, cycling leg, whatever they want, and it's affordable for them. It may be a bit more expensive than a normal shoe, but it may be affordable.
Yeah, and that's part of that inspiration and the sort of sharing culture you were talking about, is trying to lead the way. Yeah, thank you. So. Yeah, I guess a similar thing. What do you think the short-term and the longer-term future looks like for your work, Asem?
Yeah, so for the short term, I think we will see easy access for low-cost prostheses for people like in crisis-affected areas. But on the long term, people will have access for the advanced and low-cost prostheses. This is what I hope to see in the near future, because now, not every amputee can run. Not every single amputee can ride a bike. Mm-hmm. Not every single amputee can walk and feel comfortable. So I hope soon we will solve this problem.
Absolutely. And Sama, it's not just 3D printing that you use. You use all sorts of different kinds of technologies. So.
Yeah. Well. The short future, let's say, now we'll work on model a new type of prosthetic that fits our vision about the machine learning and all this stuff.
So it's raising the average again.
Exactly. Yeah. And also for the not longer future, but I'm thinking of the second version already about the prosthetic. To lose all the motors inside it and just work on some kind that it will work without motors. Okay. Just kind of small electrical shocks, and it will make it move.
Incredible.
And also after that, I'm thinking of expanding this to all kind of limbs.
Oh, amazing work. Thank you very much. I think if we take some time now to get some questions from the audience. Is there a second microphone, or are we using the same microphone?
There's a microphone for the audience.
Thank you very much. So would anyone have any questions for our champions and survivors up on stage here? Thank you.
Thank you. I wanted to ask you, do we have any kind of software somebody can easily use to create just a shape of the prosthetic to print, to basically adjust some ready-made prosthetic out of the internet, be it a leg prosthetic, hand prosthetic, and if so, can we improve it? Can we use another tools? What can we use if we want to help, for example, people in Syria to actually build them legs that they will be able to use as soon as possible and as easily as possible?
Please. Yeah, so as I understand the question, it's about helping people to do more of this, but is there some sort of basic thing which can be adapted to the individuals? Have I got that right?
You mean if it's open source or yeah. Oh, okay, well, the thing is that I thought about it is to make the model open source, and if anybody just wanted, we can chip the electronics actually for them, and hopefully the code we will have it also open source. If anybody can enhance it, it will be more than welcome. So yeah.
But you were talking about just the electronics. But do we have anything to adjust the shape of a prosthetic to somebody?
Of course. You mean if it's for kids or for adults? Yeah, of course. There will be some kind of solutions for this, but we're still in early stage, right?
It's coming.
Yeah,
absolutely. Thank you very much. And I think there's, to a certain extent, we're seeing some of that sort of example in a very unusual place, which is in dentists' offices, where they customize some of the replacement teeth and things, the implant that people have actually within the dentist's offices. And I can imagine in the future, although it's much more complex, a similar sort of thing. Another question?
Yeah, hello.
Please.
Thank you very much for this inspiring talk. Actually, it's related to the last question. In case of, and it's a question to both the makers and the users. In case of kids, right, you would have to adjust it constantly, and you would not know when and how much to adjust it. So I was wondering of your vision, Sama, would it be to have like small makeup places everywhere where you could actually do it yourself or adjust it? And for the user perspective, how often do you have to adjust it in the case of kids? I mean, you don't know how quick they grow.
Yeah.
Yeah.
Thank you.
Yeah, well, that's what we are, sorry. That's why I'm thinking to make a 3D printed model that's whenever you want to adjust it, you print a new model. I'm thinking also to have it's made for certain edges or different sizes, depend on what you need, what kind of kid, on what edge, and what kind of hand he cut. So yeah, maybe we'll find a solution about this. We still didn't create the model again. We're still in the early stages.
And
I'm sorry, it's makeable? Yes, of course. Yeah.
And do you want to say something in response to that, please? Yeah.
Well, yes, it's a big issue. When you are a child or a kid, you have to adjust the prostheses or get new ones every year, at least, depending on how you grow. And believe me, if you're a kid, you don't want to sit there getting a plastic cast 1 hour. So it would be nice to have a scan in 3 minutes and then go away, play with other kids. So this would be a nice way for kids too. And for me as an athlete, I have always the challenge with all the training I do every day. You know, the muscles grow and then we lost weight because of all the training. So I have to do a lot of adjustments all the time. So I'm basically getting a new prosthesis every year too. So I'm like a kid, but not growing, I'm just growing muscles.
Thank you. Another question there, please. Oh, sorry, I didn't see you. We'll come to you next. It's quite hard to see with his lights, I'm sorry.
No probs. Do you think that with the media coverage the likes of Enable and RoboHand get, that some parents have unrealistic expectations of the capabilities of 3D printed prosthetics on a desktop machine, for instance?
Yeah. Asem, what do you think about that? The unrealistic expectations with all of these stories that are out there.
Yeah, so 3D printed prosthetics are not the best solution ever. You know, there is the bionic hands, which cost tens of thousands of euros. But 3D printed hands, for now, for the meantime, I mean, in the future, I really believe in the low-cost, bionic, perfect arms. But for now, you know, 3D printed prosthetics are providing alternative solution for people who can't get the access for the advanced healthcare, for the advanced technologies, which cost a lot of money.
unless you have access to advanced 3D printing technologies. And I think that that's one of the things that's often come up with 3D printing, and one of the reasons why prosthetics is so popular for in the area of 3D printing is that actually the technology for 3D printing isn't quite there yet. So it's still developing, and it's these low volume, highly customizable parts where it makes sense, right? It's not necessarily for if you were responding in the Syrian crisis and you suddenly had 200,000 people who were, out of the 4 or 5 million.
So you have two choices.
Yeah.
There is like 100,000 amputees in Syria. You have two choices: to provide a cutting-edge bionic arms for 100 or 200 amputees, or to provide a basic arms or limbs for as much as you can.
Yeah.
I'm talking about the cost, but
absolutely.
We hope that in the future we will provide every single amputee we will fit him with a very good and cutting-edge limb.
And that's why your work's important, Denise, in terms of sort of raising the average, isn't it? And trying to advance the technology to make it more accessible.
Absolutely.
Yeah. Okay. Any other questions? We had one over here, and then we've got a couple at the front here. Please.
Actually, your last exchange kind of answered what I was going to ask, but do you see the future being kind of highly customizable prosthetics, or is there a way to make adjustments for existing prosthetics to then add on to customize to someone else? And so I'm just wondering about kind of the commoditization of these prosthetics, and I guess scaling on a commercial sense, but also to keep costs down. Is it about fitting everyone, or with the children that may have outgrown something in the course of like a shoe size? I mean, children grow really quickly. Is there ways to pass these on or fit people with someone else that may have a similar dimensions?
Have you seen any of that, Denise? The idea of the idea that these things might stay with a person over a longer period of time and can be adapted over time, or that you have this good average level of technology that then can then be more rapidly customized. I guess it's a question of how do you take it to scale? How do you reach so many more people?
Yeah, definitely you get more customizing in, and as well you have more try and errors, so you can definitely be more filled with more fantasy, and so with the traditional way it's not really working, that you can always go back and try something new. So very cheap.
And Sama, have you got any thoughts on this?
Well, yeah, of course. Well, yes, it's totally customizable, and the thing about if it's affordable for people or not, that's why we are using the low-cost electronics like Raspberry Pis, Arduinos, and we're trying to also make it all open source to let people actually be able to look at the code and have a look at the hardware itself. So it will be low-cost stuff that we are using, so any person can afford this prosthetics when they need it.
Absolutely, thank you. Question here. Who has the microphone? Thank you.
Could you just give us a rough estimate of the price range, what the basic prosthesis will really cost? Because I've got no idea. I can imagine it's pretty expensive to have a prosthesis for an athlete, but just give us a price range, a cost range.
Please.
Well, if you can buy the Raspberry Pi nowadays by $34 or something like that, if you want a full prosthetic, maybe it goes from $100 to $200, something like that. It's normal. It could be possible that you afford it. And if people that got less in more poor countries, we'll try to make to talk about charities and something like that to donate these prosthetics for people that they can't afford this.
Absolutely. And for yourself? So Asem, in terms of the cost of what you're making for people, what does that work out as?
Yeah, so the hand, which was in this video, costed us like $50 with the electronics. And without electronics, it will cost $30.
Okay.
While the normal prosthesis cost between, I mean the normal, not for athletes. The normal one costs between 2,500 euros up to 4,000 euros.
Okay.
The lower limbs and the upper limbs, the bionic limbs are much
okay.
More expensive.
And Denise, what have you seen in terms of the prices of these technologies?
Well, 2,000, 4,000 euros is pretty cheap. Okay. It's like if you're BK, that means below the knee, so maybe around 5,000, 6,000, 7,000, 8,000 when it's a better one. But if you're above the knee, your prosthesis, that means you need a knee, which is working. So the costs are around 12 to 15,000. And just last weekend, I met someone who is above the knee amputated, and he got one of the newest technologies, and he told me that his prosthesis costs 35,000 euros. So that's a good car to drive. So yeah, it's very, very expensive.
Yeah. And we have one more question here. Thank you.
And my question has to do with the design of these things, and especially to both of you gentlemen. Have you seen in the past, sort of a trickle-down effect where high-end equipment starts to be available at lower price points in the market? That's certainly true with the control mechanisms, because you can put a Raspberry Pi in there. But I'm worried. I'm thinking more about the prosthetic hardware directly. Okay. Because I'm interested in, should we be developing for the high end for like Denise and hoping that trickle-down effect happens, or should we be going from the bottom up, working in the poorest countries with the simplest materials and hoping we can improve that from the bottom up? You know what I mean?
Yeah. Well, I believe it's from the bottom up, because you need actually to make sure that it works on any simple prototype first. After that, you can finish it with a high end. Depending on the cost, that will be different. Some people maybe would like to have it low cost and 3D printed the model, and some people maybe would like to have a high end and buy all the model. Yeah. So that will be different between people.
And do you think how do you think, so you're thinking about sort of raising the average, but
you mean
from the bottom up?
By the quality, you mean?
Yeah.
Yeah, well, the quality that we have right now for the normal prosthetics, it's doing nothing. Yeah. It's nothing. So I'm trying to take it for above the average even. Yeah. So it would be more effective like any human hand. Okay.
And Denise, over the course of your life, how have you seen some of the really advanced technologies? Have they become more accessible? Has there been that sort of high tech coming down in cost?
Yes, absolutely. Like somebody has to do the step, and then like we had a cell phone, nobody could afford it a couple of years ago. There was been a computer, nobody could afford it. So we have a kind of role model that we have, and it takes a while, but I'm sure that it will happen to be accessible.
So it takes both. You need pioneers at both ends. Okay. I think we're going to wrap up now, but I just want to sort of finish with a closing thought. In the opening of the London Olympic Games in 2012, there was a moment when in the center of the stadium, a house lifted up, and inside the house was Tim Berners-Lee, who was one of the pioneers of the World Wide Web, and he wrote a tweet, and the message was written large around the stands of the Olympic Stadium, and it says, "This is for everyone. This is for everyone." Is that part of why you're doing it? Is that Olympic spirit part of why you're here today sharing these stories?
Absolutely. Yeah.
Yeah? Yeah. Please? Is this something you believe? Is that you're motivated by? Is that why you're choosing open?
Actually, what motivates me is to make the amputees do everything, like any normal person, or even more.
Yeah.
Because when you lost your leg, you will have the motivation to do things that you wasn't thinking about.
Absolutely.
This
and this is a very personal motivation for both of you, you know. And Sama.
Well, from the beginning, I wanted to change the world, so I should make difference.
Okay, thank you very much. So we create a better world, change the world. Survivors and champions.